So it is 11, 27, 17. So the Common Core standard really is dividing polynomials. And we're going to do it by synthetic division, okay? Okay, so if we looked at our notes in our reading, it doesn't even look like dividing at all. In fact, it looks really weird, doesn't it? But it is doing division by this thing called synthetic division. Okay, so let's put this back up. Okay, so I'm going to go through steps with you. Okay, first step, no matter what. Number one, let's start right with our upside down division. Okay, start right there. Okay, upside down division. Step two, let's put all of the numbers in. 3, 4, -2, and 4. Okay. So, to do synthetic division, we do the upside down division because it tells us we're doing synthetic division. The x's are invisible. Don't write the x's are invisible, okay? Let's put the opposite of this. Let's put a -2 there. Opposite, right? Opposite. So, if a +2, put a -2. Again, the x is invisible. It's there, but it's invisible, okay? Draw your addition line and put a little remainder box right there, okay? So, remainder box is below the constant term, okay? All right, so far so good. So we've got it set up. Now you got to remember the first term, very first step. No matter what, bring down, because you need something to multiply, right? You need something to multiply. So right off the bat, first step, bring down. Let's see if I can use a different color here. I got red, blue. I don't want that color. Oh, I'm looking for different colors. All right, here we go. Here's a blue. Okay, bring it down. Bring down the 3. Step 1, bring down 3. So I'll bring down 3. Okay. And then I multiply. Multiply. So we're going to go 3 times -2, which becomes a -6. Put your -6 right there. Okay. And then add. We're going to add. So we're going to get a -2. Okay. Then multiply, okay? Then multiply. And I get a +4, so put a +4 right here, okay? Then add. Okay, when I add, I get a +2. Then multiply, and I get a -4, okay? So put a -4 right here. And then add. So I get a 0. Now, if you get a remainder of 0, we already know that our answer is a factor. In fact, both terms are a factor, okay? So if we add, we get a remainder of 0. So what's our answer? So we have to rewrite our answer. Rewrite the answers, but put back in the x's. Now, again, Kenji asked a really good question. So we started with an x cubed, right? We started with an x cubed. So our answer, because it got divided by an invisible x, it's going to be 1 less power. So instead of an x cubed, it's going to be a 3x squared minus a 2x plus a 2. Now we know, because we have a remainder of 0, it is a factor. How's that? Here's my answer. So because it's a factor, we know this. We know that x plus 2 times 3x squared minus 2x plus 2. We know that this, if you multiply it all out, would equal that, wouldn't it? Right? We know that this times this would have to equal the original polynomial, because it is a factor. Right? What's a factor? 2 things that multiply to make another. All right, example 2, same thing. We're going to use synthetic division. So let's set it up. Am I going too fast? Okay, slide it up. Step 1, let's do our upside down division. Okay. Let's put in the numbers, not the x's. The x's are invisible. 3, 4, -2, 4. I'll put in my opposite, put in a +2 here, okay. draw my division line and my remainder box. How am I doing? So far, so good? Okay. All right. So then, let's go ahead. Step one. Step one was to bring down the first term. Bring down the first term. Bring down my 3, right? Oh, I need to do that in a different color. My bad. There you go. 3. There you go. Then multiply. We're going to multiply. So we get a 6. This is our addition line that we're going to add. That's our adding line. So we're going to add, and we get a 10. Okay. Am I going too fast? Okay. Then multiply, and I get a 20. And then we add, and we get a 18. And then we multiply, and I get a 36, right? And then I add, and I get a 40, okay? So I got a remainder of 40. It is not a factor. Not a factor. Because it had a remainder, right? So if it has a remainder, it's not a factor, okay? Pretty easy so far? Let's rewrite the answers. So the answer is going to be this. Answer is going to be 3x squared. One less power than the original, right? Right? One less power than the original because we divided by an invisible x, plus 10x plus 18. And we're not going to go remainder 40. No. We're going to go plus 40 over our x minus 2, okay? That's the answer. Yes, they are.
Could you make it 40 over x and 40 over negative 2?
No, couldn't, because, and can I answer that later when the film's off? Okay, really good question, okay? Okay, really good question, okay? So, example 3, P of 2. What does P of 2 mean? Yes, Caleb.
X equals 2.
So let's plug in 2. You guys agree? P of 2? So P of 2 really means, let's do this. All right, so P of 2 is equal to 3 times 2 cubed plus 4 times 2 squared minus 2 times 2 plus 4. And hallelujah for calculus. Would you agree with that? Because I really don't want to plug that in, right? I'm going to quit that clear. I'm just going to let the calculator do the work. Scoot up so we can see it. You guys see the calculator kind of, sort of. I'm going to get the light so I can see it. You can see it there. Can you see it there? Sure. So I'm just going to go, all right, 3 parentheses 2 to the 3rd power plus 4 times, whoops, back up, wrong parentheses, 2 squared minus 2 parentheses 2 plus 4. Okay, so everything's plugged in the calculator. You guys can see it right there, right? I put it all in there. I push enter, and I get an answer of 40. Okay, so I get an answer of 40. Okay. So P of 2 is equal to 40. Okay, great. So then I say something like, what do you notice? Do you notice anything? I know it's too early, Mr. Davies. It's Monday morning after vacation. I don't notice anything except for just my phone, right? So all I notice is just my phone. Do you notice anything? Kayla.
Calculators are amazing.
Could you divide both sides by 2? And you got P.
No, because that's P of 2 means I plugged in 2. Leora, do you notice anything?
40 is the remainder when that's divided by x minus 2.
Yes, that's a big deal. So when you plug in any number, it gives you the remainder of the division. So it's part of the remainder theorem, okay? So this is called synthetic substitution. We're going to write that down real quick, and we're going to talk about that more tomorrow. Synthetic substitution. And synthetic substitution will find the remainder. It will find the remainder. Okay? How you doing? You guys hanging in there? So big deal. Who cares? What does that, how could that possibly help me? How could that possibly help me?
The question asks for the remainder.
Yeah, but what's, okay, so let's go back to the remainder. What is the best remainder of all?
0.
Yeah. Why is the remainder of 0 the best remainder of all?
Because it means it's a
So
factor.
it's easier.
So it's easier. So yeah. So if I say, is this a factor, you could divide it out, right? Or you could say, hey, I don't know, but if I did my substitution, I get an answer of 0. I don't have to factor, but I could tell you yes or no. One more time. I'll say one more time. Is it a factor? Yes or no? Well, you say, well, gosh, I could divide it out and find out if the remainder is 0, and I could say, yes, it's a factor. Or I could save myself a whole lot of time, plug it in, and if I get 0, I'll say, yes, it's a factor. And I don't care about what the answer is. I'm just asking the easy question. Is it a factor? Yes or no? See what I'm saying? If you plug it in, you get anything but 0. You say, no, it's not a factor. But I never asked you what the answer was. I just said, is it a factor or is it not a factor? Okay, we'll talk more about this, okay? Hey, we're finally into Algebra 2 stuff. Like it. We're no longer doing Algebra 1. Hallelujah. Turn the page, okay? So now, example 4, which looks like all the rest of them, but I gave you a little hint. What's my little hint? What's my little hint?
Oh, don't forget.
Oh, there's something missing. So let's do it like we always do. Step 1, upside down division, right? Put in our numbers 1, 0, 3, negative 12. Where did that 0 come from, Leora?
Because you have to have an x squared, but since there's no x squared, it would just be 0.
Exactly. Did you see what she said? I got an x cubed, but there's no x squared term, is there? So in a sense, we could have written it like this. It's kind of dumb to write it like this, but I could have written it and say, well, this is really h of x equals x cubed plus a 0x squared plus a 3x minus 12. We could have written like that, right? Now you have to have the missing term. You've got to put it in there. And so now the rest becomes pretty easy. We're going to make sure that we put in the opposite, right? So we're going to put a positive 3. We need the opposite, right? Put my addition line. There's my addition line, right? That's my add line. See how easy this is getting now that you got the hang of it, right? Then step 1, bring down the first term, right? Bring down your 3. Am I going too fast? But you could probably do it. In fact, you probably already have it done, right? Some of you already have it done. Sarah's already done, aren't you, Sarah? So bring down my 1, and then I multiply, right? I multiply, and I get a 3. I add, and then I get a 3. I multiply, and I get a 9. I add, and then I get a 12. I multiply, and I get a 36. I add, and I get a 24. So my answer is a 1x squared plus 3x plus 12 plus 24 over x minus 3. There you go. All right. And I'm going to stop recording. And homework is not that hard. 19 to 29 odd. I do need to have you show your work, obviously. Caleb, please show your work. I don't want you to say you can do this in your head. This is not long. This is actually